So we now talk about dummy variables in linear regression. In this module, what concerns us is not the empirics behind how to calculate the coefficients of dummy variables, but we will look at more conceptual questions as to how do we assign dummy variables and other such issues related to dummy variables. So the first question that arises is, why do we need dummy variables? There are several answers to that. First is that there are several qualitative variables which might affect a variable, and hence those qualitative variables also need to be included in the regression model. Now all the regression that we have done till now deals only with quantitative variables that can be expressed in certain units. However, there might be qualitative variables which might be demographic variables, variables of behavior or characteristics which might also affect another variable. Hence, when we have to include such variables, they are included as dummy variables in the model. Secondly, we need to reduce errors by removing pooling of data. For example, there is no reason that male wages and female wages are affected similarly by different independent variables. And hence, if we put all of these samples together without differentiating between male and female samples, then we are committing the error of pooling. It would be much better instead to take a dummy variable for gender and then study if these dummy variables are different or not. The third reason is to study differences. The differences that we can study can either be exogenous differences, which are like the intercept dummy. So we say that for every wage level, males earn a certain rupee greater than females. Another case that we could consider is the different effect of the same quantitative variables on two different kinds of samples. For example, we might hypothesize that the multiplier is greater in European economies than it is in Asian economies. If we want to test the difference between the effect of the same increase in government expenditure on the output, then we can use dummy variables which can differentiate between European and Asian economies to test the difference. So two of the models that we frequently will consider in this module is first one that expresses wage as a function of education and gender, and the second which expresses graduation marks as a function of hours of studies, gender and stream. Obviously these are very highly simplified models, but they will suffice to show the conceptual issues that we want to deal with. The most important thing to notice while we are studying dummy variables is how to assign values. The first step that we do is to divide every qualitative variable into several categories. For example, if we talk about gender, then there are two categories, male and female. If we're talking of stream, we can talk about three categories, arts, commerce and science. And if you're talking about regions, then we can talk about several categories such as Americas, Eurasia, Oceania, Africa. In any category, you can also add the category of all the others. In this case, we can cover everything that we have not exclusively shown as a category. So one of these categories has to be chosen as the base category. For example, in the subsequent study that we do, in the streams we choose the science as the base category and arts as commerce as different categories. The choice of the base category or the reference category is more or less arbitrary. However, what we also must know is to how to change the base category, and we will get to that later in this module. So for all other categories except for the base category, we assign a dummy variable D. So for example, if there are three categories, then one of them becomes the base category, and for the other two we assign dummies. If D equal to 1, then that attribute is present, and if D equal to 0, then that attribute is absent. For example, if you're talking about region, then if D refers to the presence or absence of it being a Eurasian economy, then D equal to 1 will say that it is a Eurasian economy, and D equal to 0 will say that it is not a Eurasian economy. Hence, if there are n categories of an attribute, then we need n minus 1 dummy variables. Some very important things to note are that if all D equal to 0, then what we are talking about is the base category, because it belongs to none of the other categories and hence has to belong to the base category. For any one attribute, only one of the DIs can be equal to 1 for a sample point. Hence, if you talk about gender, then it has to be either male or female. If you're talking about stream, it has to be either arts, commerce or science. Note that this will be true in the case when the categories are mutually exclusive. If there are more than one qualitative attributes, then more than one DI can be equal to 1 for a sample point. So we will deal later on with the case of having more than one qualitative attribute. So the first example that we take is one of wage as a function of years of education and gender. Since gender has two categories, male or female, hence we let male be the reference category and we need a dummy for female. So our model becomes Wi equal to alpha plus beta 1 EI, where EI is the years of education, plus beta 2 DI, where DI is the dummy for female, plus sigma I. Now note that when D is equal to 1, we are talking about a sample which is a female, and when D equal to 0, we are talking about a sample which is a male. To show that more vividly, we let D equal to 1 and we get the equation Wi is equal to alpha plus beta 1 EI plus beta 2 for females, and Wi equal to alpha plus beta 1 EI plus sigma I for males. Note that there is a uniform difference of beta 2 between the wages of females and males, and hence this is what we call an intercept dummy. Similarly, a second example that we can talk about is graduation marks M, which is a function of hours of study H, gender and stream. So note that we are now talking about two qualitative variables, one is gender and one is stream. Gender is a qualitative variable with two categories, male and female. Hence we need one dummy variable which is represented here by GI. Similarly, stream is a qualitative variable for which we are considering three categories, arts, commerce and science. Hence we take one of them as the base category, in this case science, and we assign dummy variables for commerce, which is S1I, and for arts, which is S2I. So our overall model becomes Mi equal to alpha plus beta 1 HI, which is hours of study, plus beta 2 GI, which is female, plus beta 3 S1I, which is commerce, and beta 4 S2I, which is arts. We have already talked about the categorization for gender, so let us talk about the categorization for stream in this case. Given that we have taken science to be the reference category, S1I to stand for commerce, and S2I to stand for arts. Hence, if we are talking about a sample which belongs to the commerce category, then S1 will be equal to 1, S2 will be equal to 0. Similarly, for a sample belonging to arts, S1 will be equal to 0 and S2 will be equal to 1. And finally, when S1 and S2 are both equal to 0, then we are talking about a science stream student. Now, when we have two qualitative variables, then our reference category will also have two qualities. So our reference category in this case will have a gender and it will have a stream. For when it is not obvious what the reference category is, the simple way to do it is to assign a value of 0 to all the qualitative variables present. For example, if we want to find out the base category of a previous model, then set G equal to 0, S1 equal to 0 and S2 equal to 0. When we put G equal to 0, we mean we are talking about males. And when we put S1 and S2 equal to 0, we know we are talking about science. Hence the reference of base category in this case is a male science student. Similarly, when we are talking about a female art student, since we are talking about females, hence G will be equal to 1. And since we are talking about art student, hence S1I, which is commerce, will be equal to 0 and S2I, which is arts, will be equal to 1. Hence a model becomes Mi equal to alpha plus beta 1 HI plus beta 2 plus beta 4 plus sigma I. Note, and we will refer to this again in the subsequent slides, is that between the equation for female art students and male science students, which is the base category, we see that there is a difference of beta 2 plus beta 4, which is uniform no matter what the level of hours of study is. Hence, beta 2 plus beta 4 is a difference in the intercept of the two regression equations, and hence this is also called an intercept dummy. An intercept dummy is used when there is a difference between two categories of a qualitative variable which is independent of any other category or any other independent variable. So for example, taking our previous example of wages, we have Wi equal to alpha plus beta I EI, wherein EI is the years of education, plus beta 2 GI plus sigma I, where GI is for females. So G equal to 1 for females and G equal to 0 for males. Now the interpretation of beta 2 in this case will be that female wages are beta 2 units more than male wages, holding education level constant. Hence at each and every education level, female wages on an average will tend to be beta 2 units more than the male wage. Now of course beta 2 could also be negative, but let us consider a case in which beta 2 is positive. That is, in which case females for the same level of years of education earn higher wages than males. Now to see it graphically, we have drawn the two regression lines, assuming that there is a positive intercept and assuming that there is a positive slope. Now the distance between these two lines will uniformly be beta 2. So these are two parallel lines and the distance between them is given by beta 2. So for when gi equal to 1, then we are getting female wages, which is the upper line, and when gi equal to 0, we are getting male wages, which is the lower line. So for example, if both have 18 years of education, a female will on an average earn beta 2 units more than a male. This is the interpretation of an intercept dummy. Similarly, now consider an intercept dummy, in which case there are three categories of a qualitative variable. So one such qualitative variable that we have looked at previously is stream, and we are assuming that there is art stream, commerce stream and science stream, in which case the marks obtained equal to alpha plus beta 1 plus hi, where hi is the hours of study, plus beta 2 s1i, wherein s1i stands for commerce, and beta 3 s2i, where s2i stands for arts, plus sigma I. In this case, now the interpretation of beta 2 becomes the marks obtained by commerce students is beta 2 units higher than that of science students holding hours of study constant. Note now that when we are making this interpretation of beta 2, we are talking with reference to the base or the reference category, and this is the reason it is called a base category. So similarly, beta 3 will also have a similar interpretation, that is the marks obtained by art students is beta 3 units higher than that of science students holding hours of study constant. So all comparisons that we're making is essentially with the base category. To show it graphically, we assume that beta 2 and beta 3 are both negative. That is, on an average, science students score higher than commerce and art students given the same level of hours of study. In this case, the regression line between hours of study and marks is assumed to be positively sloped for all three streams and is the highest for science stream. The commerce line lies beta 2 units below the line for science, and the arts line lies beta 3 units below the line for science. So note in this case that we are assuming implicitly that beta 3 is greater than beta 2. That is, for the same hours of study, a commerce student obtains higher marks than an art student. In fact, we can make a more definitive statement. We can say that commerce students get beta 2 minus beta 3 units higher than art students. What we are assuming thus far is that the effect of the stream and the effect of gender is separable and independent. However, that might not always be true. For example, we might see that female art student performs better than male art student, but a male science student performs better than a female science student. Hence, we might see that there are differences in the way these two categories interact with each other, and hence we cannot say that these two qualitative variables are independent of each other. This is the case of an interactive intercept dummy. Very often when we say an interactive dummy, we are talking about slope dummies, but there can also be an interactive intercept dummy, as we show in this case. So for example, if we consider marks again as a function of hours of study, of gender and of stream, we can very well construct a model such as this, wherein mi, which is marks obtained, is equal to alpha plus beta 1 hi, which is hours of study, plus beta 2 gi, which equal to 1 for females, plus beta 3 s1i, which equals to 1 for commerce students, plus beta 4 s2i, which equals to 1 for art student. This is the kind of model that we have considered thus far, but now we add another term which is plus beta 5 gi dot s2i. This is the product of two dummy variables, gi, which equals to 1 for females, and s2i, which equals to 1 for art student. The product of g and s2i will be equal to 1 only for female art student and will be equal to 0 for any other category. Hence, you might see that what we are doing here is to hypothesize that being a female art student makes a difference. We can also include other categories like male science students or female commerce students, but right now, to keep the model simple and for explanatory purposes, we restrict ourselves to female art students. Now to find out the reference category, again set g equal to 0, s1 equal to 0 and s2 equal to 0. As before, we are talking about male science students. Now the interpretation of various coefficients in this model are as follows. The first coefficient is beta 1. So we say that keeping gender and stream constant, if a person studies 1 hour more, he will score beta 1 unit marks higher. Similarly, the interpretation for beta 2 is that female students obtain beta 2 marks more than males, keeping hours of study and stream constant. Similarly, we can also talk about the other coefficients. So let us take an example of S2Y. So an art student obtains beta 4 marks more than science students, keeping hours of study and gender constant. However, and this is now the more interesting part, is that if a student is both female and an art student, then she obtains beta 2 plus beta 4 plus beta 5 marks more than the reference category, that is male science student. Now, in case we had not had this interactive intercept dummy of beta 5 GI into S2I, then this difference would only have been beta 2 plus beta 4. But being a female art student gives you an added advantage or a disadvantage, which is quantified by plus beta 5, so that your overall difference from the base category goes up to beta 2 plus beta 4 plus beta 5. We can make similar comparisons with categories except for the base category. For example, when we are talking about female art students, then GI equal to 1, S1I equal to 0, S2I equal to 1, and GI into S2I is also equal to 1. Hence, we have the added benefit of beta 2 plus beta 4 plus beta 5. However, when we talk about male art students, then GI is equal to 0 and GI into S2I is equal to 0, in which case the added effect is only beta 4. Hence, female art students obtain beta 2 plus beta 5 marks more than male art students, keeping hours of study constant. Similarly, female art students obtain beta 4 plus beta 5 marks more than female science students, keeping hours of study constant. Hence, there is an added benefit to being both female and an art student, and this is the basic concept behind an interactive dummy. To show it graphically, we consider the same model that we have been considering in the last few slides, and we assume that beta 2 is greater than 0, that is, females on an average score more than males, that beta 3 is negative, beta 4 is negative, that is, commerce and art students score less than science students. However, beta 5 is greater than 0, that is, there is an additional benefit to being a female and an art student at the same time. When we show it graphically, there will obviously be 6 lines because there are 2 categories for gender, 3 categories for stream, and hence 6 categories for a combination of gender and stream. We choose to show only 4 of them. First, female science students. Second, below that is the female commerce students because beta 3 is negative. Below that is female art student because beta 4 is negative. However, the male art students, which would otherwise have been only beta 2 units below the female arts student line, is now beta 2 plus beta 5 units below the female art students line. This is because there is an additional benefit to being female art student, which is captured by beta 5. For all other streams such as science and commerce, the male category line will lie beta 2 units below the female category line. But in the case of the female art student, this is beta 2 plus beta 5 units. So thus far we've talked about intercept dummies, in which case there is a difference between 2 categories of an attribute at all levels of the quantitative variable. But as we've mentioned before, there might be a case in which the same quantitative variable responds differently in the case of 2 different categories. For example, let us consider the wage example, which is WI equal to alpha plus beta 1 EI, wherein EI is the years of education, plus beta 2 GI, wherein GI equal to 1 for females, plus beta 3 EI GI plus sigma I. Now note that this term EIGI is a combination of a qualitative variable, which is the gender GI, and a quantitative variable, which is EI, that is the years of education. Now for the reference category, which is males, G equal to 0, and the entire equation becomes WI equal to alpha plus beta 1 EI plus sigma I. For females, G equal to 1, and the equation thus becomes WI is equal to alpha plus beta 2 plus beta 1 plus beta 3 EI plus sigma I. Hence, unlike in the previous cases where we would have only seen the difference in the intercept as represented by beta 2, we now see that there's a difference in the slope also, which is beta 1 plus beta 3. If beta 3 is positive, then women are earning more for a unit increase in education level than men are. That is, women for every unit increase in the level of education are getting a salary which is beta 1 plus beta 3 units, whereas men for the same increase in years of education are getting a salary which is only beta 1 units higher. When we represent it diagrammatically, what we see now is that these two lines not only have different intercept. For example, the male intercept is alpha, whereas the female intercept is alpha plus beta 2, but they also have different slopes. The slope for the male line will be equal to beta 1, whereas the slope for the female's line will be equal to beta 1 plus beta 3, and the female line will be steeper if beta 3 is greater than 0. The interpretation of beta 2 now, instead of becoming the difference at all levels of education, will become the difference at 0 level of education, that is the intercept. So the interpretation of beta 2 becomes that with 0 level of education, a female earns beta 2 units more than a male. And the interpretation of beta 3 now becomes for every additional year of education, a female receives a wage that is beta 3 units more than that of a male. We could have also added other qualitative variables such as ethnicity or region, and then we could have similarly added other slope dummy variables to capture the difference in responsiveness to years of education. However, the basic idea still remains the same as we have presented it here. The final topic that we turn to is the tests on dummy variables. In this case, first let us consider a dummy variable in which there is this one attribute, and that attribute has two categories. So in our module we talk about the wage example, which is Wi equal to alpha plus beta 1 EI plus beta 2 GI plus sigma I, where GI equal to 1 for females. As we had talked in our first slide, we can use dummy variables to study differences between the two categories. So for example, if we want to say that males and females earn the same wage for every education level, then we have to test whether beta 2 is significantly different from 0 or not. This, as we previously done, will be a t-test. So under the null hypothesis that there is no wage difference with respect to gender, H naught, which is the null hypothesis, is beta 2 equal to 0. Under H naught, beta 2 by standard error of beta 2 will follow a t distribution with n minus 3 degrees of freedom. We take n minus 3 because there are 3 parameters alpha, beta 1 plus beta 2 that we are estimating. If the null hypothesis H naught is rejected at whatever confidence interval that we have chosen, then there is evidence of wage difference with respect to gender. Hence we see that the test that we do is essentially the same as the test that we would do for another quantitative variable. In the case of more than one category, for example if we choose streams, then we have two dummy variables, S1i which is equal to 1 for commerce students and S2i which is equal to 1 for art students. If our null hypothesis is that there is no marks difference with respect to stream, hence we would say that beta 2 equal to 0 and beta 3 equal to 0 at the same time. So our null hypothesis H naught is that beta 2 equal to beta 3 equal to 0. What we are essentially now doing is to run a test for linear restrictions taking beta 2 equal to beta 3 equal to 0. Hence under H naught we run two regressions. One is the unrestricted model, which is mi equal to alpha plus beta 1 hi plus beta 2 s1i plus beta 3 s2i plus sigma I, and the other is the restricted model with beta 2 equal to beta 3 equal to 0, that is mi equal to alpha plus beta 1 hi plus sigma I. So we obtain the r squares for both of them, which is r square unrestricted and r square restricted. Under H naught, r square unrestricted minus r square restricted by the number of restrictions, which is 2, divided by 1 minus r square divided by n minus 4 will follow an f distribution with 2 degrees of freedom in the numerator and n minus 4 degrees of freedom in the denominator. If this H naught is rejected, then there is evidence of a marks difference with respect to stream, and hence we can conclude that the stream matters. So the basic idea that we are trying to show is that when there are more than two categories, then we have to use the simultaneous linear restrictions test. Finally, for further reading, you could refer to one of these two sources, and this brings to an end our discussion on dummy variables.